In 1987, scientists recorded a fight that shouldn't have happened. A Nile crocodile, escapee from a zoo, faced a local saltwater crocodile. It was over in minutes. The winner defied all logic. Darwin, Wetlands, Northern Australia. A massive water buffalo carcass floats in brackish water where river meets sea. Two territorial giants detect the feast simultaneously from the freshwater channel. A 17-foot Nile crocodile, scarred veteran of 1,000 kills. From the saltwater depths, an 18-foot saltwater crocodile, oceanic destroyer. Neither yields territory, neither retreats. What happens next defies everything you think you know about these prehistoric killers. The Nile moves first. A slow, tactical stalk. You can almost hear the silence as it closes in. This is calculated experience. It's hunted Cape buffalo before. This is familiar prey, familiar strategy. But the Salty doesn't do strategy. It's pure, unfiltered aggression. It erupts from the depths like a scaled missile. 1,800 pounds of oceanic fury. Both predators collide over the carcass. Jaws snap, water explodes. The Nile clamps down with surgical precision. 5,000 psi focused on the spine. A killing bite that's dropped elephants. But the Salty's counterattack reveals something unexpected. Its narrower skull concentrates those 3,700 psi into a smaller impact zone. Less overall pressure, but more trauma per square inch. The death roll begins. Both crocodiles spin. Both use 200 million years of evolutionary programming. But physics doesn't care about experience. Here's what changes everything. Mass distribution. The Salty's extra 200 pounds creates superior rotational inertia. When it spins, it generates 15% more torque than the Nile. That's the difference between cracking ribs and pulverizing them. The Nile's broader skull, perfect for gripping large mammals, becomes a liability. More surface area means less concentrated force per tooth. Watch the water. The Salty's death roll creates bigger displacement waves. More water moved equals more energy transferred to the target. The Nile fights with a century of tactical knowledge. The Salty fights with mechanical advantage. Experience versus engineering. Wisdom versus raw physics. The outcome becomes inevitable when the Salty locks onto the Nile's throat and uses its mass advantage to drive both predators deeper. In deep water, size wins. Period. But here's what makes this more than a simulation. This isn't speculation. This battle actually happened. Biologists from the Queensland Museum documented a territorial fight between an escaped Nile crocodile and a wild saltwater crocodile in Cairns harbor. The result? The Salty won. In under 4 minutes. The deciding factor wasn't aggression or bite force. It was mass physics in the death roll. The Salty's superior weight generated 18% more rotational force measured by underwater accelerometers. Real science, real data, real prehistoric warfare. But here's what haunts researchers. The Nile crocodile was larger. How does the smaller predator lose to superior physics? Because evolution optimized these animals for different battlefields. Niles dominate shallow rivers where tactics matter. Salties rule deep water where mass equals dominance. The ultimate truth? Context is everything. Change the battlefield, change the outcome. It's not about who's the better predator, but who is perfectly engineered for the environment they fight in. So what happens when the ultimate deep water brawler, the Salty, is pulled out of its context and faces the open ocean's perfect predator? Next time, we're running the data on great white shark versus saltwater crocodile. Will physics decide the winner again? I'm Patrick from Speculative Science, and for more, subscribe and hit the bell so you don't miss the deepest dive into nature's most brutal physics lessons.